welcome. We have a really great presentation for you this evening. The moderators will introduce our guest speaker, but first I'd like to tell you a little bit about our moderators. We have two fabulous students from Brockton High School, the Brockton High School. Roy Rattler III is currently a junior and has an aspiring career in astronomy and astrophysics. He loves to look at everything and question everything about nature and what have you. And he enjoys teaching others things about the things that he knows about nature. He's all into the STEM field. He's also a volunteer at the Rose Conservatory and the Blue Hills Conservatory. Great kid. Young man, sorry. And then we have Isabel Tao, who is also a student at Brockton High School. She is a sophomore, and she is one of my favorites because her favorite subject is math, just like my favorite subject for those of you who know me. So I'm very proud of her for that. And her interests are art and music, left brain and right brain, and believe it or not, she loves chilly weather.
Me too.
Yes. So without further ado, I would like to introduce to you Mr. Roy Rattler III and Isabel Tao. They will be your moderators for the evening.
Good evening. Good evening. So, welcome to this special welcome to this special Planet Earth Family Fun Night. You may recognize our special guest from your TV when you're watching the news. We're lucky to have our guest, David Williams, from Channel 5, WCVB, to teach us about New England weather. Yeah.
Isabel coming up too? Different time.
Oh, at different times.
Different time? Okay,
Yes.
perfect. All right, then I'll switch out with you. All right, great.
Thank you so much for the introduction. I will not move the microphone, so we'll keep it exactly right here. So I have a little bit of a presentation for you. This is the presentation that I typically give to schools when I go and visit them. So we're going to skip past the intro video because it might be a little too young for everyone in here. It's usually meant for 3rd grade, 4th grade, 5th grade, so there are not a lot of 3rd, 4th, and 5th graders in here. So we'll just skip right past the intro video. So to talk a little bit about myself, and I also want to start with saying this is a very interactive presentation. So if you have any questions at all, please don't hesitate to stop me, raise your hand, shout it out, whatever you'd like to do. I'm here to talk with you, not to talk at you. So we're going to start with where I'm from. I'm originally from Queens, New York. That's where I was born and raised. After I was a little bit older, high school age, my parents as well as my sisters, we moved to Charlotte, North Carolina. There I went to high school. I also went to college. I went to the University of North Carolina at Charlotte, and that's where I got my Bachelor's of Science in Meteorology. So that's what you need in order to start your career as a meteorologist. So after I started my career, or once I was able to start my career, you first have to move to a smaller place. That smaller place was Amarillo. It happens to be a part of the Panhandle of Texas. That also happens to be the only part of Texas that receives snow. There, I had an opportunity to forecast snow. Also had an opportunity to storm chase because it happens to be a part of Tornado Alley as well. So a really great place to start your career. A lot of weather was happening in the Panhandle of Texas. So after I gained some experience, I was able to move. The next place that I moved to was Richmond, Virginia. There, I had an opportunity to deal with tropical systems, tropical storms, hurricanes, you name it, tornadoes, snow, etc., etc. After I gained some more experience, then I was able to move a 3rd time. So this has now been my 3rd stop, and I've been here just over 2 years, and it's been great so far. We've seen a lot of weather over the 2 years that we've been here. So we'll start with winter weather, because that happens to be the Super Bowl here in New England, right? So the last, say, 2 years haven't really been all that, how do you say it, exciting, right? So if we think back to last winter, if you guys can think back that far, sometimes it's a little difficult to remember what you did yesterday, but if we think back to last winter, by a show of hands, how many of you think we saw a lot of snow? By a show of hands, how many of you think we didn't see a lot of snow? That is correct. We did not see a lot of snow. Now when we're Usually getting our measurements for snowfall, there are two climate sites that we use the most. One is located at Worcester Regional Airport, the other is located at Boston Logan Airport. So we're using Boston Logan Airport for this presentation and for the purposes of this presentation. So at Boston Logan Airport, we picked up 9.8 inches of snow. How much snow we typically see in an annual year? 50 inches of snow. So that's a big drop off. And if we think back to 2 years ago, we saw just over 12 inches of snow. So we've had two back-to-back years where we haven't seen a lot of snow. Now thinking back to January of this year, we saw over 8 inches of rain. Now that is a very wet month. If we were just a little bit colder, that would have been all snow. And maybe years ago, we would have been colder, and that would have been snow. But now we're adjusting to a new climate, where unfortunately we're seeing very historic rainfall events, and we're also seeing warmer and warmer months. January, February, March, all warmer than average. Those are the months that we typically see our most snowfall, right? So when we're using January, we saw over 8 inches of rain. Now we skip along to February. That month, we didn't see much of any rain, and we only picked up half an inch of snow. For the entire month of February, we did not have a single day where we were at 32 degrees for a daytime high or colder. So that means that February was very warm. Well, we need cold air. If we don't have cold air, then we don't get snow. And with that as well, we need, at this point now in fall, we need some rain. We haven't seen rain in quite a bit of time. Since the 1st of September, it's now been 52 days since then. 44 of those days have not had rain. So that means we're starting to see a bit of a pattern, a drastic pattern. Either we are in a pattern in which we see a lot of rain, or we're in a pattern in which we don't see a lot of rain, or we're in a pattern where we're seeing historic highs, or we're in a pattern where, get the point, right? We're seeing changes in our environment, something that we have not been accustomed to over the last several years. So comparing last winter to some of the least snowiest years on record, we saw 9.8 inches of snow. The least snowiest year on record was 1936, 1937. That winter season, we saw 9 inches of snow. So we were only about 0.8 inches off from being the least snowiest year on record. Now, the snowiest year on record happens to be 2015. I know there are some people in the crowd that are very familiar with the year 2015. We saw over 110 inches of snow. Now, the likelihood we see something like that again, very low. So when we're talking about winter weather, there are 3 precipitation types we like to focus on: snow, sleet, freezing rain. Now when we're talking about snow, easiest one to remember. Just for the purposes of this presentation and not to get a lot of glazed looks, we'll just say it's cold high in the sky, cold down to the surface. Really easy to remember, right? Now there's a second precipitation type that usually cuts into our snowfall totals, and that happens to be sleet. Now the difference between snow and sleet is sleet forms as snow high in the sky, but it falls into a pocket of warmer air. We all know what happens to that snow. It either partially melts or fully melts, turns into rain. Now there happens to be another pocket of air. That pocket of air happens to be colder, and it's a little bit higher up from the surface. So that now rain quickly refreezes, turns into little ice pellets, and that's what we call sleet. Now sleet makes roadways very slippery, makes sidewalks very slippery. Can't make snowballs out of it, you can't make snowmen out of it. It is not a precipitation type that you want to deal with. It is not ideal. Now, the third precipitation type that we want to talk about is freezing rain. Now, similar to sleet, similar to snow, starts off with snow high in the sky, falls into a pocket of warmer air, and then has an opportunity to melt. Now, that pocket of colder air isn't as deep. It's a bit more shallow. It's closer to the surface, where we happen to be. Happens to be 32 degrees at the surface. So that rain doesn't have an opportunity to refreeze into sleet. It falls as rain, but at the surface, we're 32 degrees or colder. So we know what happens to that rain. It immediately freezes on contact. So sometimes you might not know that you're dealing with freezing rain unless you watch the forecast. Or if you go outside and try and open your car door and it's frozen shut. Or you look at tree branches and there's a layer of ice on tree branches. Or maybe you lose power because it only takes half an inch of ice to snap power lines. Now, freezing rain, probably one of, if not the most destructive precipitation type during wintertime, because it causes the most power outages. So we never really want to deal with freezing rain. Of course, snow causes power outages as well, but freezing rain on a completely different clip. So freezing rain, sleet, two precipitation types that make winter very dangerous because it's very difficult to treat ice. Snow, a little bit easier to treat because you can plow it, you can put salt down, etc., etc. So when we're talking about winter, those are the three precipitation types that we typically focus on, but of course, there's rain, but you know, that's a precipitation type that you see in winter, fall, summer, spring. So we're not gonna focus on rain. We're just gonna focus on those three for now. So before we move on to the next topic, were there any questions from the audience? Yes.
How is your electronic forecasting devices affected by power outages caused by storms?
Our electronic forecasting devices impacted by power outages. Yeah, good question. Yeah. So the question was, how are our electronic forecasting devices impacted during storms? Correct? Perfect. So at news stations, we have backup generators. We have a lot of technology. So to be honest, I've never been at a news station where our technology has gone down, even in some of the most horrific storms. And that's probably by design. It's because if there's bad weather outside, you probably want to be on air talking about it. But good question, though. So the question was, how do we determine whether it's just climate data or whether or not it's climate change? Yeah, good question. So usually when we're talking about climate change, we're comparing multiple different time periods, right? And we're comparing that over a course of time. Is that, okay, perfect. And we're comparing it over the course of time, right? So if we see the last several winters have been warmer consecutively, that speaks to climate change, right? Or if we're just measuring, let's say, over the course of time for the month of July, and it measures up to what we've seen in the past. So let's say for July, the average high on July 5th is 80 degrees. If over the course of the last several decades, typically it averages out to 80 degrees, it's on par with what we're expecting. Perfect. Great questions. Were there any other questions? Oh, you guys got it. Okay, perfect. So then, oh, sorry, a few questions in the crowd. Right here. Good question. Yeah. The question was, do we just guess? Yeah, honestly, let me get back to the mic. Question was, if you get a forecast wrong, do we just guess? Yeah, so it would be great if we just guessed. It would make my job a whole lot easier. I would love to just guess, but no, we don't just guess. We, like anything, right? You look at all the information that you have available to you. You put together a forecast, whether that happens to be 7 or 10 days out in the future. Now, the goal for anything that you do in life is you want to do a great job. You want to be right all the time. But that's just not how it works realistically. So I would say, and I would stand by my forecast 100% of the time. Now, with accuracy, when it comes to meteorologists on air, we are accurate more than we are not, right? We're accurate more than 80% of the time, really more than 90% of the time, especially when we're talking about within a day. So there are times in which we are wrong, and people remember those because it happens very infrequently. But most of the time, we're right. You know, and I'm not saying that in like a braggadocious way, like, hey, we're always right. But if you were to like sit down and compare what actually has happened versus our forecast, it usually matches up. Great question, though. Were there any other questions that I made? Yeah. So the question was about snowfall in the decades after 1937, or the years after 1937 into the 1940s, into the 1950s, et cetera, et cetera. With 1937, because that was the least snowiest year on record, 1937 was an outlier. So the years to follow after that, there were years that balanced out to being on par with what we're accustomed to seeing. Now, over the last several years, we've seen less snowfall than what we're typically accustomed to seeing, if that makes sense. Yeah, great question. Any other questions? Yeah, you got a question? You forgot it? Okay, if it comes back to you, let me know. If it comes back to you, let me know. Perfect. So we're going to move on from winter weather. Not to say that you can't ask any questions about winter weather. If you have a question, just let me know. I'd love to answer it. But we're going to move on to the Atlantic hurricane season. So we still happen to be in the Atlantic hurricane season. It ranges from June all the way through November 30th. Now that doesn't mean that we can't see tropical systems outside of that time frame. So we've seen tropical systems in the month of May, for example. Now this year was anticipated to be a fairly active year, and it has been active, especially throughout the later half of the year. So it was expected to be active a little bit earlier on. It wasn't, but now we're really starting to pick up ground, because a lot of you probably have been paying close attention to Helene and Milton. Those were two storms that were very devastating for multiple different regions. So when we're talking about the Atlantic hurricane season, the 2 months that we typically see the most hurricanes, August and September. Reason being, that's when the Atlantic waters are at their warmest. So those are the months that we typically see the most tropical activity. Now here in New England, we don't see a lot of tropical activity, which is great news, right? You don't want to see a lot of tropical activity. It's very devastating. But the last landfalling hurricane in the state was Hurricane Bob. That happened in 1991. That was a Category 2 hurricane, caused a lot of damage. Now we haven't dealt with a landfalling hurricane since then. Now with climate change and waters becoming warmer and working their way a little bit farther north, the likelihood that we see a hurricane retain its strength as it continues to march farther north, if it is able to make that turn, is starting to increase year by year. Now, this year, last year, have been the warmest years on record when it comes to sea surface temperatures. Now, we're not just looking at sea surface temperatures when we're talking about hurricane development. There are a lot of factors that go into hurricane development. And we won't get into all of those factors because it would take quite a bit of time to explain all of those factors. But we typically use sea surface temperatures because that is the energy source for these systems. So we've seen about 15 named storms this year. 10 of those have been hurricanes. So those are a lot of hurricanes, right? And what we're also seeing is when these hurricanes form, they become major hurricanes, and very quickly at that. So between 2017 to now, we've seen more major hurricanes hit Gulf Coast states than any other time in history. And unfortunately, that seems like that's going to continue in the years to come. So when we're talking about hurricanes, we'll explain the life cycle of hurricanes. And I'm going to say typically because this isn't always how it happens, but we'll say typically because of the purposes of the presentation, and if it were to be explained in a textbook, this is exactly how it would be explained. Now, we'll keep it very simple. Just off the western coast of Africa, we might have a cluster of showers and storms. That cluster of showers and storms continues to move over warm Atlantic waters, and the National Hurricane Center will draw a big circle around it and say, hey, this isn't bothering anyone right now, but maybe over the next 7 days, it has an 80% chance of development. So as time goes on, those clusters of showers and storms continue to become organized, get a little bit stronger. So it goes from a tropical wave, which is just a cluster of showers and storms, it gets upgraded to a tropical depression. At that point, it gets a name. So now we have Tropical Depression David. So Tropical Depression David continues to get stronger and stronger. It gets upgraded again to a tropical storm. Tropical Storm David continues to grow and get stronger. Gets upgraded to a hurricane, and that's when we get an I. So once you see an I in that storm, it is now a hurricane. When we're talking about hurricanes, we're looking at categories. Categories 1 through 5. Major hurricanes, categories 3, 4, and 5. Now, when storms hit land, or I should say hurricanes specifically, or any tropical system, when they hit land, they lose strength very quickly. So we'll use Hurricane Milton, for example. It went from a tropical storm to a Category 1 hurricane to a Category 5 hurricane in under 24 hours. Now that is rapid intensification, and unfortunately we've seen storms recently undergo rapid intensification pretty consistently. So what that means is bad news for those that not only live in Gulf Coast states, but bad news for really a good chunk of those, not only in the Gulf Coast states, but even along the East Coast, us included. So as these storms continue to get stronger quicker and make landfall as these strong systems, we're going to see more and more damage in those areas, right? When we saw Helene earlier this year, we saw Milton earlier this month. These types of storms, unfortunately due to climate change, may become a bit more frequent and even more devastating than we've already seen, and they've already been pretty devastating. So I have a video of, hopefully it works, fingers crossed. I have a video of some damage of Hurricane Ian, so this was 2 years ago, just to give you an idea of how devastating these storms can be. It's a time-lapse video, so we don't need sound. It seems like I'm just going to get hit with ad after ad, so we're just going to skip past it. We have time, we'll go back to it. But we'll skip past hurricanes now, and we'll talk a little bit about tornadoes. So when we're talking about tornadoes, here in the state of Massachusetts, we don't see a lot of tornadic activity on average. We typically see 1 to 2 tornadoes per year. Now, if we think back to the summer of 2023, if you guys can remember a little bit about that summer, it was a really wet summer. We saw a lot of rain consistently, especially over the weekends. And a lot of people weren't happy about seeing rain on the weekends, myself included. I did not want to see all that much rain. But not only did we see a lot of rain, but we also saw quite a few tornadoes. We saw 8 tornadoes throughout the summer of 2023. Now, the reason being, we're dealing with not only a lot of rain, but a lot of convection. And with that, when we're talking about tornadoes, there's specific criteria that needs to be met in order to have an environment that is conducive for tornadoes to form. Now, this previous summer, good news was, it was a pretty average summer. We didn't see a lot of rain, and of course, we did not have a lot of convection. Now, when we're talking about tornadoes, it's always good to know what you're dealing with so that you can take shelter, stay there until that storm passes. So, here in the state of Massachusetts, we see 1 to 2 tornadoes per year. Where I started my career in Texas, that happens to be the state that sees the most tornadoes out of the country. They see over 100 tornadoes per year. I believe it's just over 150 tornadoes per year. The United States alone sees over 1,000 tornadoes per year. So we are the country that sees the most tornadoes in a given year out of any country in the world. We average the most tornadoes. So definitely something you want to keep a very close eye on at all moments in time. When we're talking about tornadoes, they're usually short-lived in nature. They last less than 10 minutes on average. And most tornadoes are of the weaker variety, usually EF0s, EF1s. So with that, they're usually quick spin-ups, they do quite a bit of damage, and then they're done. So it's really difficult to not only forecast tornadoes, but it's really difficult to know exactly when a tornado may hit. So when we're talking about the threat of tornadoes in a given area, it's always good to have all of your electronics charged, just in case something goes left that you weren't necessarily anticipating at a specific given moment in time. We're still getting better year after year when it comes to forecasting tornadoes. We have not gotten it down to being able to say, hey, a tornado is going to form within this mile of land here, right? All we can say is the environment is conducive for tornadoes, let's say, throughout the eastern half of the state today. That's a really, really big area. And not everyone is going to see a tornado. But if you're able to just know in the back of your mind that there's a potential, you're able to make the necessary adjustments to ensure that you're safe. So the last, I would say, really significant tornado to impact the state was in Springfield, Massachusetts, 2011. That was an EF3 tornado. It did quite a bit of damage. We haven't seen anything that strong since then. Even with the summer of 2023, most of those tornadoes were EF0s or EF1s. It's not to say that they don't do quite a bit of damage, they do, but good news was we didn't have any fatalities for the summer of 2023. So this is a video as well. We will skip past it because I will probably get hit with an ad. So we're just going to skip along to what you may see behind me if you turn on the TV. This is what we call a radar scan. So to talk a little bit about what this means, so you know what you're looking at. Rain, right? But different levels of rain. So if you look at the green here, that's light rain, and it incrementally goes up from there. So green, light rain. Yellow, heavier rain, moderate, right? Then we go to orange and red. Now that's very heavy rain. That rain is difficult to drive through. It's difficult to see. Now the purple on this image right behind me, that is hail. That is indicating that there is hail within that thunderstorm. Now the size of that hail sometimes is dependent on how, how bright that purple appears. So the brighter the purple, usually the stronger the chance not only that there's hail, but also that there may be some large hail within that thunderstorm. Now, the image right next to it, if you see that red box, that is a tornado warning. That is issued by the National Weather Service. That is not issued by broadcast meteorologists like myself. So when you have a tornado warning and you live inside of that tornado warning, or you happen to be inside of that tornado warning for whichever reason, you're going grocery shopping, visiting a friend, doesn't matter. If you happen to be inside of that red box, you need to take shelter immediately. Because with a tornado warning, that means a tornado is imminent. That means that either a tornado will form very shortly or possibly has already formed. If it has formed and it's detected by radar, or it is confirmed by someone on the ground, that box will go from red to purple, and that will let us know that it is a confirmed tornado. So it is no longer the chance of a tornado forming, it is now a confirmed tornado. So it makes a bad situation even worse. So when we're talking about tornado warnings, and we're talking about tornadoes, as we just covered, they're usually short-lived in nature. With this tornado warning specifically, good news was, actually bad news. That was a confirmed tornado, now that I think back on it. Yeah, that was a confirmed tornado. So when we're dealing with tornado warnings, it's always good to treat it as if there actually is a tornado currently on the ground. Because you don't know if it's going to be coming toward you, going away from you, until that warning has either been allowed to expire or it has been canceled. So we have a few examples to wrap up the presentation here. I have 3 examples. Either it's going to be a tornado, a hurricane, or a winter storm. So by a show of hands, how many of you think this is a tornado? Raise your hand. How many of you think this is a hurricane? Raise your hand. Okay, great. So this is a hurricane. This actually happens to be Hurricane Beryl, which also reached Category 5 strength. But with this radar loop, this was a Category 4 at the time of getting this radar loop. So this one might be a little bit more difficult, but we already saw what a hurricane looks like by satellite. So 2 options, either a winter storm or a tornado. How many of you think this is a winter storm? How many think it's a tornado? Great job. So this is a tornado. This actually happens to be a bit of an infamous tornado. Maybe some of you are familiar with it, maybe you're not. This was the tornado of 2021 in Mayfield, Kentucky. This was specifically notable because it was an EF4 tornado, and it happened at night. So unfortunately, there were a lot of lives lost and a lot of damage as well. Now, there are several different panels here, and we'll try and simplify it as best as possible. So this panel right here, this happens to be reflectivity. You see a hook pop up from that reflectivity. That's what we call a hook echo. And with that hook echo, that's letting us know that there's really strong rotation in this particular thunderstorm. Now, if you look at the image just to the side of it, you see a lot of reds, a lot of greens. That's what we call a velocity scan. So if those reds and greens are touching each other or cupping each other, that's what we call a couplet, and that's letting us know that there's a really strong rotation within this thunderstorm. Now, sometimes it's difficult to tell if that rotation is reaching the surface. Now, one of the products that we use is what we call a correlation coefficient, i.e. a debris signature. So if you look on the bottom image here, this is what we call a debris signature. Now with this, what you would want to see is all of these colors be the same. So you want all of that to just be that kind of like reddish pinkish color, right? That means good news. It means there's possibly no tornado on the ground, possibly, not always. Now, unfortunately, what we see with this is a big blue blob over Mayfield. So with this debris signature, that is letting us know that there's debris being tossed into the sky. Whether that happens to be trees, cars, houses, people. It's letting us know that things are being tossed into the sky that aren't supposed to be there. So that's what we're looking at when we're looking at tornadoes. Now, last but not least, easiest one on the on the presentation. This is a snowstorm. Easiest way to tell. You see all the whites, you see the blues. So we're dealing with some fairly heavy snow. And fun fact, of course, it does not have to be 32 degrees at the surface for it to snow. Now, it does need to be 32 degrees for it to stick pretty efficiently. We have seen snow stick to be maybe a few degrees warmer than 32 degrees, but for it to stick efficiently, you want it to be 32 degrees or colder. And then just off the coast, you see a little bit of rain mixing in. It's a little bit warmer out that way. But yeah, that was it. Thank you guys. I appreciate it. Thank you for watching some. Yeah, that's a great question. So, great question. So yes, when we're talking about hurricanes, they actually do cause tornadoes to form, especially on the front right quadrant of a hurricane. Let me see if I can go back to the slide here. So right here with Hurricane Beryl, for example, where the tornadoes would form, let's say it were to hook back, and let's say once it goes straight through the Caribbean islands, it were to hook back and take aim at Florida. On the front right side of the storm, that's where all of the convection is, and that's where winds are also the strongest. So when you're dealing with hurricanes, there are a lot of hazards you have to watch out for. If you're on the front right side of a hurricane, there is a likelihood that you will see tornadoes. Not only will you see tornadoes, of course, with hurricanes, you have storm surge, hurricane force winds, flooding rains. Hurricanes are bad news. They're bad business. So yeah, when you're dealing with not only just hurricanes, but even the remnants of hurricanes, that can also cause quite a few tornadoes and, of course, flooding conditions. Like with Hurricane Beryl, for example, it gave New York, I believe, the most tornado warnings they've seen in a given day. So yeah, it's something you need to keep a close eye on, for sure.
Did you say why there are more tornadoes in the United States than any other?
Yeah, great question. So the reason being is we have the perfect mixture of warm air and cold air. So we have that cold, dry Canadian air, we have that warm, moist Gulf air. So toward the middle of the country specifically, and even toward the Gulf Coast states, that's where that perfect mixture is happening very frequently. And that's why those states that see 40, 50, 100 tornadoes per year, they're really bumping up our averages, right? Like New England, we don't see that many tornadoes. So yeah, we just have the perfect mixture. We have the perfect ingredients. Yeah, I know, right? Yes.
So my question is about tornadoes too.
Yeah.
I grew up in Michigan. I unfortunately a lot of devastation to neighbors and backyards. Back then we used to have like tornado watches, tornado warnings.
Yeah.
I know that when you showed your graphic, it was red to yellow. The red means favorable, and purple means it was one. Where back in the day, I remember the watch was favorable, the warning was there is one. So just trying to get a little clarification.
Yeah. Great question. So the question was about the difference between tornado watches and tornado warnings, and the difference. I'll try to go back to the slide to show here. Let me see if it allows me to go back. Yes, so the difference between a tornado watch and a tornado warning. So with a tornado watch, it means, of course, those, like you pointed out as well, tornado watch means the conditions are favorable, but that doesn't mean that a tornado has happened. So you can have a tornado watch and no thunderstorms yet, right? Now, when we're talking about a tornado warning, that means that a tornado is imminent. So if you happen to be inside of that red box, there's a fairly high likelihood that a tornado may form within that given area of that box. So that's it is confusing though, I see where you're getting at. So with the tornado watch, it is also red. It is also red. So I'll say this, with the tornado watch, it won't necessarily look like this, it'll just be a lot of counties lit up in red. But with a tornado warning, it usually is always a box. So it's a specific area, it might not be like the whole state, and sometimes with the tornado watch, it might be half the state, or like the whole state, or a certain chunk of the state. But with a tornado warning, it's usually like a really specific area, and it's not going to take up the entire state because, yeah, it's usually only impacting a specific area.
One quick follow-up.
Of course.
With the tornadoes, we're seeing the climate changes. Are we expecting to see more of those, just like we were expecting to see more hurricanes?
Yeah, great question. So speaking to climate change, yeah, if we use 2023, the summer of 2023, for example, where we had really an outlier year, where we saw 8 tornadoes. So that's not normal here in Massachusetts. So yes, I think with our climate changing, we'll see not only more thunderstorms, but we'll also see more severe weather in the way of possibly tornadoes as well. Yeah, of course, thank you. Yes, all the way in the back.
So where is the best place to live?
It's a great question. That's a great question. Where's the best place to live on this earth? I've actually asked myself this question, and I actually had this conversation with my uncle the other day. No matter where you live, you're dealing with something. It just depends on what you want to deal with. Now, I'll say in New England, we're not going to see as many tornadoes as Texas sees, no matter how bad climate change gets. I think we still will never see 150 tornadoes per year on average, or more than that. Now, we'll see years where our winters are complete washouts, and we still may see years where winters are very snowy. That's just the way that climate change goes, is you see the opposite side of the spectrum in a drastic way consistently. So yeah, to answer the question, the best place to live, you have to probably do a pros and cons list, figure out what you're willing to put up with. But yeah, I know I don't necessarily want to live in Florida. Yeah, that seems pretty difficult. But you know, shout out to all the Floridians out there that are able to brave through it. Yes.
I read once that in the span of the 20th century, the temperature was going up pretty consistently, except for the 60s. But the 1960s were cooler. Did you ever encounter an explanation for that?
Yeah, great question. So the question was that we've seen a rise in temperatures over the course of decades, but the 1960s specifically was cooler. Great question. I will say I'd have to do a little bit more research into the 60s specifically to give you a really, really good answer. But without looking at the numbers right in front of me and being able to kind of piece together myself, my best educated guess would be that we will see years that are exponentially warmer, and we will see years that are cooler. So that kind of just goes into the same umbrella of climate change, is you'll still have opposite side of the spectrum, but it'll be so drastic instead of where we should be, which is average, if that makes sense.
Yeah, it does, actually.
Good, fantastic, of course, thank you. Yeah.
Do tornadoes have like eyes like hurricanes do?
Yeah, great question. Do tornadoes have eyes like hurricanes do? No, they do not. They form under different processes. So when we're talking about hurricanes specifically, it's a low pressure system. When we're talking about tornadoes, they're on a much smaller scale, and they're most of the time associated with thunderstorms. Not always, but most of the time. Yeah. Mm-hmm.
Are AI and computer modeling used to help predict weather?
Yeah, is AI helped, does AI help us predict weather events? Now, we are using AI. It is helpful, but yeah, I'll leave it at that. We do use AI, and it is helpful. Absolutely. Mm-hmm. So tornadoes, great question. Tornadoes actually don't have a determined path. So when you're talking about tornadoes specifically, they can go in any direction. They're unpredictable, unfortunately. Now, they usually do follow the direction of a thunderstorm, but not always. Sometimes it can veer off path. Yeah, of course.
So, if a hurricane was going from west to east,
Okay.
I know that's abnormal.
Yeah.
But would the right foot quadrant still be the strongest side?
Yeah, so depending on where the hurricane is forming. So I'll revamp the question a little bit. So if a hurricane were to form in the Gulf of Mexico, front right side, still the front right side. If you have a hurricane coming from, let's say, the Caribbean islands, front right side, still the front right side. So no matter which side you're looking at a hurricane from, the front right side is still going to be the worst area of the hurricane.
My last question.
Yeah, of course.
So, I've seen on the news about extratropical like hurricanes.
Yeah.
What's the difference between a tropical cyclone and an extratropical cyclone?
Yeah. So what's the difference between a tropical cyclone and an extratropical cyclone? So we're talking about tropical systems has tropical characteristics. When we're talking about an extratropical cyclone, it's now lost its tropical characteristics. And that usually happens when it's going farther northward, like toward colder waters. So we're no longer talking about the tropics, and it becomes extratropical. Usually the wind field expands. Or let's say it's moving over land and it gets downgraded to, a tropical depression or an extratropical cyclone. Yeah, great question. Of course. Oh, good. Oh, fantastic. Well, yes.
How did you get interested in weather?
Oh, great question. Yeah, great question. How did I get interested in weather? When I was growing up in New York, I really loved snow. And I would always wake up and I'd watch Al Roker specifically. yeah, it was a whole lot of fun when I was a kid. Not as much fun when you're an adult because you have to clean it.
Yeah.
But as a kid, yeah, I had a blast, and I just kind of stuck with that as I got older. And I watched Twister when I was younger too. Really loved that movie as a kid. As an adult, I still really love it, but I understand there's a lot of inaccuracies. But it's still a whole lot of fun to watch, and the new one was a lot of fun to watch too. So, yeah, I think snow started my interest, and then it just took off from there.
What's the worst storm you've ever been in?
The worst storm that I've ever been in. There was a tornado warning. I'll use two. No, I'll use one. There was a tornado warning when I was in Texas that was directly over our news station, and it had softball-sized hail. So, windows were cracking. My car ended up becoming pretty dented. People lost windshields, and rain just started going sideways. And luckily, there wasn't a tornado that formed, but it was a really nasty tornado warning and severe thunderstorm. So, yeah, that was probably the craziest experience, because Texas, lights started flickering. I was like, what's happening? Yeah, it was a pretty crazy experience. Absolutely. Great question. Yeah.
So you said you did storm chasing.
Mm-hmm.
What was your most favorite experience storm chasing?
That's a good question. I don't know if I have one. I'll be honest. He said, what was my favorite experience storm chasing? I don't know if I have a favorite experience storm chasing, because every experience I had storm chasing was scary, as bad as it sounds. Yeah, so I was actually really happy when I didn't have to storm chase. When I first started out, because I'll be honest, I really didn't know what I was doing. Like, I knew how to get to the storm, I just didn't know how to get out of the storm. So yeah, I got myself in a lot of hairy situations that I didn't need to. But now that I'm a few years older and I have a better handle on what things are doing, I would be better at it. So I still want to do it again, but yeah, when I was doing it, it was not fun, I'll be honest, yeah.
What's the importance of storm chasing?
Yeah, the importance of storm chasing. We're able to provide information to those that happen to live in the area or might be in the path of said storm. So if there's someone that happens to be chasing a storm, able to get video, able to get pictures, and send that into, let's say, a news station, or maybe even share it on social media. The people that happen to live either in the path or in that area now have an idea of what to expect. So we're able to give people possibly life-saving information that they're able to use in order to stay safe from whatever storm happens to be headed their way. And storm chasers usually help with recovery efforts after a storm is rolled through too. So certain towns that have been demolished by tornadoes, sometimes storm chasers are the first people on the scene to provide relief. Yeah, great questions. Mm-hmm. Yeah, of course.
Is there technology available that allows storm chasing to be done remotely?
I mean, yeah. The question was, do we have technology available that allows us to storm chase remotely? Really, I think you probably still have to have someone on the storm because the whole purpose of storm chasing is to have a visual. So unless you might use a drone or something, but I don't know how a drone might get damaged. So I don't know. I don't know if you can do it remotely. I mean, like there's someone that could be, in studio or like live streaming on YouTube and have storm chasers out on the storm and just videoing and using that video, the storm chasers out chasing the storm. But I don't know if you can necessarily do it remotely, if that makes sense. Yeah.
So I saw in the news about hurricanes, there was a terminology like rapid intensification that kept getting said.
Yeah.
What is it defined as?
Yeah. Rapid intensification, it means a storm is undergoing rapid strengthening. That's just a really fancy way of saying it's strengthening at a very high clip. So use Hurricane Milton, for example. It went from a Category 1 hurricane to a Category 5 hurricane literally within hours. So yeah, when we're talking about rapid intensification, it just means a storm is quickly strengthening.
Is there like a specific speed that it has to increase by to be determined as rapid?
Yeah. We use, let's say, pressure, for example, like millibars. So if it drops a certain number of millibars within a certain amount of time, then it's rapidly intensifying. So for Hurricane Milton, for example, I believe it got to 897 millibars. That is really low. That is some impressive strengthening. Yeah, great question.
A little bit off topic, maybe, but hurricanes go what? Clockwise?
Counterclockwise, yeah. Yeah, they go like that. Yeah. Just clockwise, it's like that. Hurricanes go like that. I thought clockwise was like this one. Yeah. No, it's all good. It's all good.
The point that I was trying to make is, do they go the opposite direction in the Pacific?
Do they go the opposite direction in the Pacific? In the southern hemisphere, when we're talking about like typhoons, are you talking about typhoons specifically?
Cyclones, yes.
I don't believe so. I'll double check, but I don't study the southern hemisphere that frequently, so I'll have to double check. Yeah, I'm not well versed in typhoons. I'm well versed in hurricanes, but yeah. Why do hurricanes spin? So they're low pressure systems. So if you ever look at, let's say, even a nor'easter, for example, right? There's certain counterclockwise motion that is associated with low pressure systems. So when we're talking about low pressure systems, a hurricane is just a low that's lost its fronts, if that makes sense. So like a low pressure system might have fronts, like a nor'easter, for example, has fronts. It might have a warm front, might have a cold front. Now when we're talking about hurricanes, those fronts are now shed. So you're just dealing with that counterclockwise rotation.
My husband told me he had seen in the fall that there was some kind of a warning in western Plymouth County, but he never saw what kind of a warning it was. Today.
Yeah, today?
Today. Did you?
So we had elevated fire risk today. Yeah. We had an elevated fire risk today because low humidity, gusty winds, warmer temperatures. Yeah, I think that's.
Now I can go home.
Of course. I'm glad I could help. Yes.
So has the weather team looked ahead to see what is forecast for our coming winter? Do you have any inside knowledge?
Yeah, I got you. So the question was, what is this winter going to hold? So bad news is it looks like another warmer than average winter. Now that doesn't always translate to less snow, but in this specific scenario, I think it may translate to lower than average snowfall. Now things can change, of course. It only takes one big storm to take us over the top. So big storms can still happen, but it doesn't look like it's shaping up to be a cold and snowy winter, if that makes sense. Of course. Good deal. Okay, good. Yeah.
El Niño and El Niño, how do they affect our weather?
Yeah. So it's the warming and cooling of ocean temperature. So right now we're going into a La Nina. So usually that translates to a winter that is not as necessarily snowy. Now with El Niños, usually you're dealing with a little bit more moisture. Now it doesn't always translate to a snowier winter, but it does mean you're dealing with more moisture. Now, sometimes I know you probably have heard about the polar vortex and things of that nature, but if we're dealing with colder air that links up, we might have a snowier winter. But there are a lot of different things that have to link up for us to get a really blockbuster winter. And as you guys know, the last few winters, that just hasn't really necessarily linked up.
Does climate change affect La Nina?
Oh yeah, El Nino, La Nina and El Nino. Not necessarily. Yeah, not necessarily. Those patterns will happen. Those patterns will happen. Yeah, great question.
I have a question about that.
Yeah.
So if climate change affects sea surface temperatures, and El Nino and La Nina is based on sea surface temperature as well,
Yeah.
how is it not affected by it?
Yeah. So these patterns, it's kind of like, I'm trying to figure out the easiest way of describing it without going down a super deep rabbit hole. But with certain patterns, there's always ebbs and flows. So yes, with sea surface temperatures, specifically when we're talking about the Atlantic hurricane season, so between the months of, let's say, June all the way through November. Now, when we're talking about El Nino and La Nina, these are timeframes in which the entire year is impacted. So La Nina or El Nino will impact whether or not how warm the ocean may be or not be for a specific hurricane season, but it's not in reverse, if that makes sense. Like, those sea surface temperatures are not going to impact those patterns, if that makes sense. That pattern will impact the sea surface temperature. You know what I mean? Yeah.
So in the future, if the sea surface temperatures increase over time, will it be a period of just there will never be like La Ninas because of the increased sea surface?
No, there still will be ebbs and flows. So we'll still see La Nina and El Nino. Yeah, there still will be transitional periods, absolutely. Yeah, great question. Great question. Well, thank you guys. I appreciate it. Thank you so much for your time.